everybody. In this video, I'll be going over Learning Target 18, where we can apply our knowledge of increasing and decreasing intervals as well as concavity to draw a possible graph of a function that satisfies some conditions. So let's just jump into these conditions. We have that f prime of x is greater than 0 on these two intervals here. And f prime of x being greater than 0 means that f is going to be increasing from negative infinity to 1 and 1 to infinity, which is pretty much everywhere on the graph except that specific point 1, which makes sense because we have a vertical asymptote, x equals 1. And what I'm going to do is I'm going to draw a vertical dashed line, which acknowledges that asymptote. This isn't actually part of the drawing of the function because the function can't exist at x equals 1, but it's just there to help us realize that. Finally, let's look at the concavity conditions. We have that f prime or f double prime of x is greater than 0, which means concave up on negative infinity to 1 and 3 to infinity. And we have that f double prime is less than 0, which means concave down on 1 to 3. And given all this, we can determine that there's an inflection point at x equals 3, because we go from a negative concavity to a positive concavity. And the reason we don't count x equals 1 as an inflection point is because there's an asymptote there. All right, so we pretty much have worked out all these conditions. Now it's just time to actually draw this graph. So starting at negative infinity, we know that f will be increasing, and also based on the third condition, f double prime is greater than 0, so the concavity is up. So we'll draw increasing, concave up, part of the function there. And since there's an asymptote at x equals 1, I'm not going to let that part of the graph touch x equals 1. Next, we know that our function will still be increasing, but it'll be concave down from 1 to 3. So I'm actually going to go in regarding this inflection point, just draw another little vertical dashed line to mark our inflection point. Since this is an asymptote, and we know we'll be increasing away from it, and will be concave down, I'm going to draw something that looks like that. And then, does not mean that to auto fit. Something like that. We know at this point, it's an inflection point, so the concavity changes, but we're still going to be increasing. It's subtle there, but you can see we're kind of trending this way, and then now we're trending back up, if that makes any sense. That's the inflection point, is we're changing a concavity. We're concave down here, now we're concave up. And that's pretty much it. We sketched a graph of the function. There's a lot of different ways you can draw it, but this is probably the most general way. Just to summarize it, given these conditions, we took what we had, we determined where there's an asymptote, we determined where we're increasing and decreasing, and also the concavity. And then you really just, as you go in each region, you just need to consider all those different conditions it gives. So we knew we'd be increasing, concave up here. Here we knew it'd be increasing, concave down. In this last little section, will still be increasing, but concave up. Yeah, that's pretty much it. It's not super complicated. It's just really make sure you read those conditions, understand what those conditions mean in terms of the f primes and f double primes, and then just put it all together.